Hi, yes, we're back on the Gigatron PCB and doing some stuff in KiCAD, because if you saw my previous video, which I'll link in if you haven't seen it, where I compared the difference between a 2-layer and a 4-layer PCB for H or magnetic field radiated emissions, and that was a very interesting video. A lot of people really liked that because no one had really taken the exact same design and showed the difference between a 2-layer and a 4-layer PCB before, and a lot of people asked, like, could I actually do the 4-layer PCB a bit different? I.e., well, in this particular case, you'll notice that this is the 4-layer PCB I did. It has your traditional ground and power in the middle and the traces on the top and bottom. Can we zoom into that? Unfortunately, I don't think we can show the inner layers inside there. Anyway, and this is your traditional method because you, say for surface mount parts, you want to route your traces on the top and bottom. You don't want to have your surface mount parts and then immediately drop down via vias down to the inner layers, and then it just ruins your routing density and all that sort of stuff. But for through-hole board like we've got here, there's no reason that the signal layers had to be on the top and the bottom. So a lot of people said, hey, what's the difference if we actually bury those layers, those signal layers in the middle, all these traces in here with all the loop area that's radiating everything? What if we buried them inside the copper plane? So have the ground and the power on the outside and the two signal layers on the inside. So hey, it'll be an interesting experiment. So I'm going to do that now. So what I'm going to do is I've created a duplicate version. I'm still running 5.00. I know there's a later version, but I just want to use the same one I've already got installed. So let's actually load this up. All right, so let's drag it over. And by the way, thank you to people on the KiCAD forum, because this is actually tricky. I couldn't figure out how to do this, and I'll explain in depth shortly. And somebody, I think, basically had the right approach. Thank you, EEVblog. Here, a lot of people said I'll show you in a minute. There are other techniques to do what I want to do to actually swap all these layers, because I don't want to relay out the board. I want to keep everything absolutely identical. So let's actually load it up. So I've created a duplicate board here. Okay, so we've got where, if we take off the layers here, okay, we've got our top and bottom layers here, and then our inner copper VCC and ground like this. Okay, so now what we want to do is swap these layers, and as it turns out, like, there is a layer swap tool. If you actually go in here, and there's a move and swap layers, and you can actually go there and you can kind of sort of do it, but I found it didn't actually work. It didn't do exactly what I wanted. So what I want to actually do, this is trivial to do in Altium. I used to do it all the time in Altium, and as it turns out, it works a similar way here. It's just that I couldn't actually find it. So I want to move all of these top layer traces here to the inner layer, which is currently called VCC, like that, and I want to move the bottom layer ones to the inner layer here, which is ground. So if we go to our Stackup here, we've got a 4-layer board. Now you can actually do this many different ways. You can create extra layers and then copy them the extra layers, but I don't think we have to actually do that. So what I'm going to do is first I'm going to change VCC and ground from power planes to signal planes, because effectively we're doing polygon pools anyway. So it makes, polygon, or zones as they're called here, copper zones. So it makes no difference. So let's actually change those over to signal layers. Okay, first of all, we'll just delete our plane here. I could probably drag it off or move or swap the layers and stuff like that. I just don't want to. We'll just do it from scratch, shall we? Because if we go in here and then we select this layer here, I don't think we can actually swap the layer of that zone. So we're going to have to place a new zone. Maybe there is a way to do it or whatever, I don't know. But anyway, we'll delete our copper zones, and you'll see all of our nets are now unconnected. All of our positive, which is called H. That's just the designers on the schematic chose the name H for high and L for low. They're actually VCC and ground. Okay, so all these nets are unconnected. That's what all these nets here mean. Now, if we go back into our top layer, or FCU, fuck you. I'm sure it's a running joke in the KiCAD forum, is it? Anyway, what we can do now is simply, I'm still getting used to they got to hold down the middle thing. Anyway, let's select all of our items in here, but unfortunately it selects all the components. But we can go in there and we can select and we can filter our selection, and by default it's got everything. So we don't want footprints, we do want tracks, we don't want vias because we can just leave them there. We're actually just swapping everything over, and hopefully because the vias need to go to a certain net, hopefully it won't screw up the nets and everything else. So I want to turn everything off, and all we get selected is our tracks. Like that. Fantastic. Okay, so we've got just our traces now in there, so we can actually go in, let's right click, and let's go into properties like this. And then for the traces, unlike the zones, it gives you the ability to simply change the layer that you're on. Now, I've tried to actually copy and paste to another layer. That doesn't seem to work, so don't do that. Altium has an option when you paste. It's like paste on this layer. So you can take something from another layer, highlight it, copy it, and then paste it to the current layer. It looks like that KiCAD does not have that option. Anyway, we can simply just transfer those traces right over. Bingo, they're gone. And the vias, as you can see, are still all the same nets and everything like that because we're not changing anything else. And if we go into copper, if we go into VCC layer, bingo, our traces are now transferred into there. And we can go and do an identical thing to the bottom layer. It's too easy. We just highlight like that. And, filter selection. Traces, that's it. Boom. Properties. Boom. Ground. Done. And bingo, we now have the VCC and ground layers, which we'll have to rename, of course, because they're no longer that. We can just go into, let's just call it inner top and inner bottom, like that. And we'll leave it FCU and PCU. It doesn't matter. And we don't have to change that back to power plane. There's no reason for us to do that because it's going to give us the positive. I don't think it inverts it on the gerbers. Anyway, we still have all these traces. So now we have to go in and we have to pour our copper. So let's go to the bottom first. We'll pour our bottom copper and we'll place a copper zone like this. And we don't want to go too near the edge. That's annoying. The board is actually off the grid, so I can't like put it an exact distance away. That's kind of annoying, isn't it? It's like half a grid. Maybe if I change the grid size. 25 mils. There you go. Change the grid size. So we're good to go. Let's, we can scroll down to low, L, or we can apply a filter and then we can just find it like that. That's probably easier. We're just going to leave it because I believe I used all the defaults last time, the thermal relieves and everything. So it's going to connect to the low. You see that low is unconnected at the moment with all those rat's nest nets. So let's go all the way with LBG over here. I am going to do something special on this board in a minute. I'm thinking about taking the copper all the way to the edge, but I won't, just for cleanliness. Just for, you know, good practice. I won't take it all the way with LBJ right to the edge. There you go. And I can actually complete that, I believe. I think you can right click and close zone outline. Boom. Okay, we're in. Now, it's exactly the same as before. Yes, the copper before did not go through the pads. It's just the, that was those clearances I chose in there. I'm going to leave that exactly the same. So this is not technically best case because if you were, like loop areas would be flowing around like this. You know, if you had a trace connected in here and the return path had to get from this bit of copper over to here, then it would have to go right around here instead of going through the individual pins. So this ground plane is not as good as it could be, but you saw the dramatic difference in the previous video of the radiated emissions between the 2-layer and the 4-layer. So I'm going to leave it exactly the same. Now, the top layer, we can do the same. Now, I said that I wanted to do something special on the top layer, and I'll explain in a minute. I'm going to actually take this back a significant margin here. Let's just say center of that. H, apply filter. Still not used to using KiCAD, but it really doesn't take much doing to learn it. It's pretty good. So is that the, yeah, I'll just take it at the center of those pads just because, and I'll explain what I'm going to do in a minute. I have a devious plan. Why didn't we get it connected? Oops. Once again, I didn't have it selected. That's really annoying. I didn't have the layer selected, even though it's disconnect. Like, how can you work on a non-displayed layer? I reckon that's wrong. Anyway, I've selected it with the blue thing here. Maybe if I was in single layer display mode, it would have been. Anyway, whatever. Okay, let's do that again. I like how it centers when you, you move your mouse pointer, and then when you zoom in with the inner mouse wheel, it centers on that. That's really quite nice. Close zone outline. Bingo. There we go. So now you'll notice that all the rat's nests are gone because our, there it is, H is being connected. And if you go through to the bottom layer, you'll see that all the L's are being H. What? Did I screw the pooch? Have they both got H? Yeah, I've created. Don't send that out for manufacture. Your ground planes are shorted. What have I done? Probably screaming at me. I don't like that you can't click in the middle of that layer. I find that really annoying. Copper. Bottom copper is L. Yeah, I think I just... I completely screwed that. There we go. Top is now connected to that. It's just testing you, making sure you notice. Okay, so our top layer, but you'll notice that our top layer is pulled back from the edge like this. Because what I want to do is also, not only do I want to see if there's a difference between having the grounds on the outside and ground and power on the outside versus the inner layers, and there will be, it's just a matter of how much really. In terms of H-field emissions, far-field emissions, once again, and when I have these three boards, different types, the 2-layer one, the 4-layer with the grounds and power in the middle, the 4-layer with ground and power on the outside, this will give me some fantastic references to do some far-field measurements, perhaps in an OAT site, an open area outdoor test site, even in my own lab, or at a full compliance EMC test house. That'd be really cool if I can swing that. Anyway, so the H. Oh, we've got a net over here. Hello. Why aren't you connected? What's wrong with you? You're connected. Look at that. What's going on? Got two perfectly good thermal relieves going in there. There's nothing wrong with that at all. That's bull dust. Anyway, top silk, I changed that DaveCAD 4-layer outer. Have you got an innie or an outer? 4-layer outer. There you go. What I want to do is actually see if it makes any difference if you put copper tape around the outer edges. Now, of course, you wouldn't do this in production, of course, but a lot of boards, like especially RF ones and things like that, might have the edges actually gold-plated as well, and they're connected to the ground plane, sort of like to form like a shielded box around everything. So all your signal layers are enclosed inside, so it can't like radiate out the sides and stuff like that. So what I want to do is add some extra copper on this top layer here, but it's got to be connected to ground. I can't have the power there. So I'll add in some extra copper fills in here, some extra zones, non-copper zone properties. No? Because right, there you go, because I've got the bloody silk selected. There we go. All right, still getting used to this. Here we go. Right, so I want it connected to L, which is my ground. Okay, yeah, happy. Can I create a polygon that... No, I'll just create four overlapping polygons. Thank you very much. Oh no, I could do it as 2 overlapping polygons. Look, here we go. Look, I'll be fancy pantsy. Look, right, I'll go over to here. here, here like this. We'll pull it back, okay? So I don't want it to be touching the other ground, the positive one there. And we'll go like this, and we'll go up here, and we can close zone outline, and that, unfortunately, because there's nothing to connect to, the zone is there, but it hasn't created, like it hasn't connected through to copper. So what we'll do, copy a via. Oh, hello. What's wrong with that trace? That trace sucks. Look at that. That's terrible, Muriel. I could place a via, but I want it to be exactly the same. Like, and I don't know what the current settings and all that sort of stuff are. Paste, and then I'll change it there, shall we? Through, net, L, boom, like that. And if we repour, how do we repour our copper? Can we just hit OK? Will that, yep, there we go. So it's now, it's decided to lay that copper down there because we've got the one via. So I'm going to put a bunch of vias around here. Oh yeah, look, it's split it down here. There you go. So I'll also put the extra one around the outside, and that'll be connected to ground. And then we have to expose the solder mask as well, top and bottom, so that we can see this. I'll spare you the details. I'll go to the finished product. Well, that's annoying. I just copied this via here, and it did not automatically copy the net as well. So there you go, that's a thing. But I find that if I now paste another via in there, it should connect. No, it doesn't. It doesn't automatically connect. Is there an option? That is really annoying. Wow. Use net class, no. Design, yeah, that's really annoying. Maybe there is a way. I'm not going to say there's not, but that means I can't bulk copy. I can't just paste them and have it. I've got to go in and manually change it. Really? That's annoying. I'm sure the KiCAD experts will tell me, no, there's a way to do that. No, there probably is, but if there's not, there damn well should be. So I don't care if these are exactly... If I was laying out a board for real, I would make sure that these are all evenly spaced or whatnot. But you'll see this all the time. We're just, by placing the multiple vias here, we're just lowering the inductance of around the outer edge. And some people go insane. They actually stitch like vias all the way around and create like a Faraday cage. They don't want anything seeping out, but because we're going to put the copper tape, it literally doesn't matter. So, oh, actually I've run into a problem. I tried to go into the 3D viewer, and it really does not like this. Unable to find the next graphic segment, endpoint, edit graphics, making them continuous polygons each, cannot determine the board outline. Anyway, see, we've got solder mask over our, what the hell? What the hell has happened to all our pads? That silk screen. What looks funky? Something has gone horribly wrong with this 3D viewer. Wow, that looks funky. Kind of like that font. Maybe we should trademark that font. That looks pretty groovy. Heavy metal or something. We'll call it the heavy copper font. I'll get back to you. I have no idea why this 3D view has done this. Wow. Let's go down to, we can do this by going down to our front mask here, and then once again place in a zone, or do we have to do a keep out area? I'm not sure. Oh, and our 3D viewer's back. Okay, look, our pads are fine now. It's come good. It doesn't like the board size. For some reason the board size has been screwed. Once again, like, this is like the first time I'm using KiCAD, so please bear with me. Oh, I think zone was the wrong thing to do. You don't want to do a zone. I'm going to kill that zone. I think we need to place. Geez, that's taken a while. Not responding. I saved it, didn't I? Oh, there we go. Okay, place. No, what we want to place a polygon. Sorry, I screwed the pooch. Front mask. Okay, here we go. Now we can do this. Watch this. Watch this. Like this, boom, and all the way up. Boom, and end. Oh, well, we can't. There, like that. There we go. Once again, it's taken a while. I think we've got an error there. I've introduced some sort of issue. If we go into 3D Viewer again, bingo, our solder mask has been removed. So now we've got this copper, exposed copper all around. I've got to do the same on the other edges, plus on the bottom as well. And then I'll have these exposed, if I get it gold plated, probably, yeah, probably will. And then I'll have the nice gold plated things, and I'll be able to actually put some copper tape over around the outside if I want to do that thing where I seal it up. It's just a maybe. It's, you know, once again, I wouldn't bother fixing that pad either. Like, I just, you know, this is just a board for experimentation purposes. I'm not going to dick around much. Aha. Is that our furphy down there? Ah, okay. I think that's been moved. There you go. That's what was causing that issue there, I think. There you go. So I fixed the edge cuts, which is the board outline, and you can see that our solder mask, there's no solder mask on the corners or anything like that, so we've got exposed grounded copper all around the edge like that. That's just so that maybe if I want to, I can do an experiment. But once again, I still haven't done the bottom side there. I'll finish that now. There you go, that's the bottom layer. And for those curious, yes, you can actually take solder mask directly to the edge, unlike copper, which creates copper burrs and stuff like that, especially when you're removing solder mask like this one. So if we go up in our 3D viewer, you can see that now will be complete. There's no problems taking that directly to the edge. That's top and bottom. Oh, we got our stupid pads again. Got our stupid pads. Anyway, we got our copper. I have no idea what the hell's going on there. Wow. Just wow. It's just rendering all those pads wrong. All right, because some people are going to ask, how do you get your board to have these gold-plated edges like this? Well, this is called edge plating. It might be called, you know, something different at some other fab, but any fab should know what edge plating means. So what you wanted, if you wanted to do that, then obviously here's the side of the board here. We can see that in, let's turn off our contrast mode. There you go. So we've got, let's just turn on our edge cuts and our top layer. So what you'd want to do is actually take your copper right to the edge like this, and then somewhere on your fabrication drawing down here, for example, you might, this one doesn't have any fabrication notes, but sometimes you would have like a fabrication layer. Yeah, I don't think we have any drawings user, no. But often you'll put all of your fabrication notes on your board like this, and you'll have all your specifications. I want FR4, I want Rogers PCB material, and put the particular part number you want, and I want this tolerance, you know, I want 4 thou tolerance, I want gold plated, you know, immersion gold, for example, and I want edge plating, please. You will specify that either on your drawings, or you can just simply do it in the email to them, or it might even be an option on an online PCB manufacturing tool. When you upload your gerbers, for example, there might be an option for edge plating. I don't know. So, but generally I've just done it manually in the past. You just tell them I want edge plating, and they will do that as a separate process for you. And if you don't take the copper to the edge, maybe they might do it for you. They might expand the copper out until right to the edge. They'll do whatever they have to give you that edge plating. And, you know, usually you want it connected to ground. Usually, almost always is ground, and then connect top and bottom like that. You can get just the edge plating without it being connected to anything. It can just be floating there, but really, apart from looks, there's no electrical reason to do that. But in this particular case, I don't want to do that, because I want the option to be able to measure this with no edge plating, because that's like a standard board would to have no edge plating on it. So that's why I've peeled it back from the edge like that. Okay, so we're actually good to go now. Let's go into our 3D viewer. That's what our board is going to look like. We got no... I don't think there's any way to show edge plating in the 3D view. So yeah, it's just like you just have to specify that manually. But that's, look, that's all right. And we've got our exposed copper around the edges, which is ground, top and bottom. Good. So I have the option. So that looks all good to go. That's looking pretty groovy, isn't it? I like that. So yeah, I don't know where the bug is where that causes all the funky copper font and everything else. But anyway, so we're good to go. So now, really, we want to do our ERC thing. I'm still don't know what's causing this. Like, why is that still showing that as a net? I don't know. Anyway, so now we want to do our DRC before we do our gerbers, because you want to make sure that you haven't screwed the pooch. So design rules checker, we want that in there. Let's list, once again, you can put in your tolerances and stuff like that here. There's options to like refill all your zones before performing DRC. Unless you've got a special circumstance, I wouldn't recommend doing that because you can screw the pooch. Because there's steps here. You go in, we've done our layout board, we've verified it in 3D mode. 3D mode is brilliant for, it's what you see is what you get. So you use that as an inspection tool. We've done that. You lock everything down. Then we'll do our final you can do that after your DRC, but we'll just, in this particular case, we'll do our DRC. We might find one or two little errors. We'll fix it. We'll do the 3D view again and lock it all down, and then we're good to go. So you wouldn't want to refill all the zones and do the DRC and then just generate the gerbers, because refilling the zones, you might have changed your clearances, your tolerances, you know, and all that sort of stuff. And your zone, you may not get like copper through here, for example. You wanted copper through there, but you accidentally didn't realize that you changed the clearances in there for the copper zones and stuff like that for the copper pores. So you could find that it was working before when you last viewed at it, but now, oh, all your copper's broken in here and stuff like that. So really, you know, just be careful when you refill in zones. Report all errors for tracks. Check footprint courtyard overlap. That's like if the footprints, you can specify a courtyard of components, whether any components are overlapping. If you've got a chip here and a chip here and they're overlapping like that, then it'll flag that as an error. It's a mechanical DRC error essentially. But if you haven't generated courtyards for it'll be called different things in different tools. In KiCAD, it's called a courtyard. If you haven't specified a courtyard for your component, then you won't have that feature. Anyway, we can like just go list unconnected. Here we go. We've got 2 unconnected items. Pad 1 on fuck you. And yeah, look, there it is. Yeah. Like, why is that unconnected? Why that? If we generate that gerber, this copper will be here. Our board will come back. It'll be fine. So there's something that's wrong with, we can just go edit. Can we just edit the properties of that? I don't know why these pads are weird like that. I mean, when we've poured that copper zone, we've poured that copper, and the software knows that it connected to this pad. Otherwise, it'd just leave the gap right around like that. So it knows to put in those thermal reliefs. It knows to connect it. It knows to connect it up here because it's put in these thermal reliefs. So why that is showing up as an error? There's got to be something subtle in there, or it's some sort of bug. So I don't know. So it's not uncommon unless you're following very strict procedures where you have to have 0 errors. Like you're at the design review meeting before your board gets manufactured. If you've got a ridiculously complex board like one of these things, you know, if you've got if you've got something like this, you've designed this board here, for example, right? You've designed this board, or it's some other huge PC motherboard or something. It's taken you a month to lay out this board, which is not uncommon, by the way. I've had boards that have taken me a month or 2 to lay out, right? They're absolute, like, you know, and this one's not enormously complex, but this is a pretty advanced board. This is going to be like an 8 or 10 layer job or something with all these huge 1,000 pin count BGAs, right? There's a lot of work that goes into that, and it's probably an expensive board to get that manufactured, especially when you've got to solder the chips on and everything else, right? You don't want to goof this up, right? So there's probably going to be a design review meeting. Foo. there's going to be a design review meeting for this board. So they're going to say, well, show us your DRC report, for example. And there's ways to fudge. Of course, you can fudge your DRC report. But if you've got someone cluey in the design review meeting who goes, well, show us the constraints that you used for your DRC. That's what I'd be asking for. Show us your constraints to see if you're fudging the DRCs, because anyone can you can have a board riddled with errors and get your DRC errors down to 0. So that you can produce your report and go, here it is, there's no errors, but it's riddled with problems. So it's all about the constraints that you set up when you do your design rule check-in and your ERC. Your electrical rules check-in. ERC is for schematics, electrical rule check-in, and then DRC is for design rule check-in, which is for PCBs. And in this particular case, we could ignore that. I'm absolutely confident, and we can verify our gerbers that this would be fine. So I could go, look, I just want to send this board out to one-off. Doesn't matter. I could just ignore that. So, I don't know. It's probably easy, but I don't know why it's doing that. Aha! I found it. Look at this. I'm on the bottom copper layer at the moment, and look, L and H nets are shorted together. Yeah, L and H. So why it's only giving me that one error? Maybe it's suppressed all the rest. So, oops, did I forget to re-pour a poly, did I? Let's re-pour poly, put the kettle on. Nope. Look at that. That's interesting. The only thing that the only net we're going to connect to is L. We re-pour that and it goes over the H net. What the? Oh, I've poured multiple ones. I've done multiples. Look, it's got a H. Yep, that's when I goofed it up before. Oops, sorry. Get rid of that. Move that one back. There we go. Is that it? I have to redraw that. You'd think it'd redraw after moving, wouldn't you? Okay, now we're good. And then I've got to go back to the top. H, and now H, and if we run the DRC again, I think we'll find we're good. So there you go. That's interesting that it didn't flag like hundreds and hundreds. There should have been hundreds of, at least dozens of shorted connections there. Oh, well, why it listed them as unconnected? That's the other thing. So let's just run that design rule check, list unconnected. It still thinks that they're unconnected. What? Have I done the same thing on the top? Nope. There's no other hidden polygon under there. So, nope. So that's interesting. Why it actually, that was a massive error. I had those ground planes shorted together, and if we got that board manufactured, if I ignored that, there's only one unconnected pad, but I hadn't done the DRC yet. But once again, let's go up here, design rule check, we'll start the DRC. Okay? Boom. That's it. So maybe it would have given hundreds of errors before or something. I should have checked that. Track near via. Oh, look. There's our little red arrow. What's wrong with that? There's nothing wrong with that. Aha, I was wrong. It is only reporting the first error because I didn't have this checkbox ticked. Here we go. Report all errors. This can be slow. If unselected, only the first DRC violation will be displayed. So, yep, there we go. So, start DRC again. And two track ends too close. Track near via. Okay, so now, there you go. Trap for young players. Young KiCAD players. So, these are all my DRCs with this board. So, track ends too close. Track near via, we know about. Okay. What's track ends too close? Why are the track ends? They're not tracks. There are no tracks there. So here's where we have to go into the detail. Net bus 7, 16 on layer inner top. Oh, oops. Yep. Inner top. Here we go. Silly me. Have I? Yep, there you go. I placed those vias without any thought for the tracks on the inner layers. Oh, that was dumb, wasn't it? And I didn't have any online DRC to tell me that I was being naughty. There you go. So that is correct. All right. No worries. Why'd they have like 6 markers or whatever? Anyway, well, yeah, have I screwed the... I thought that I was away. Thought I was nowhere near them, but yeah, there's a couple down there. So let's run that design rule checker again. Bingo. None. We're done. That's it. They were all our DRC errors. So we've got, yep, all tracks. So we're searching all tracks. We're using minimum track. They're the specs. So minimum track width 0.2, minimum via size 0.4, minimum micro via size. We don't have any micro vias. So we're good. List unconnected. The only issue we still have, non-copper of C6. I still don't get it. Is that it? It's got to be that. And you want to make use of the high contrast mode here. You can just go H, which is quite nice, and then flick through the layers. But like, how that's a thing, that's nuts. Could you know, like there's nothing extra. Like sometimes you might have something extra hidden under there, but there's not. Like if you click here, so if we go here, for example, like you need to clarify the selection because it knows there's both a pad there and a track there. It asks you what one. So if we go over here like this, it just knows that's a pad. There's nothing else hidden under there. Right, so I think we're done. All of our traces, our inner layers, our top, that's our top copper. We've got the ground around the outside. It's exposed. We've got and then the VCC plane, and we've got the inner top layer. We'll call that layer 2, and layer 3, which is the inner bottom. They're all our traces. And B, bottom copper, that's our ground plane. So I think we're good to go. I mean, we can, turn on the silk and have a look at stuff like that. If you're really that keen. Front silk, there you go. And I'm not going to fuss about any more details. Solder mask. I think we're good. I think we're good to go. I'm going to generate our gerbers now. So I'm just going to ignore that error. Seriously, I just pretty confident that's not going to be a problem. I could Kamigatsa. Also, we could actually run the cleanup. Delete track segments conflicting with different nests. Delete redundant vias. Merge overlapping segments. Delete dangling tracks. Don't want any dangling tracks. We can do that, but I don't think we had anything because our DRC didn't like unconnected nets. There was only that one up there. Is that gone now? Let's, out of curiosity. What and the which, how or why? For you Aussies will know what I'm talking about. List unconnected. Nah, it's still there. Anyway, there's our 3D view. So you want to go through your 3D view, like go in, check it all out. Like simple stuff like silk screen over pads and things like that. And the great thing about this is that it is rendered in what you see is what you get. Like sometimes you might not want silk screen over your vias or something. If it's a nice important silk screen, you might go in and shuffle your tracks on a pro board, for example, if you're really caring about that sort of stuff. But generally, I think we're good. I think we're good to go. The blinking lights. So we're going to want a drill file, PostScript, Epsilon, drill units. We want millimeters. Decimal format, generate drill files. Yep, outer plated through holes, non-plated through holes. Separate them. The manufacturers can deal with that, no problem. We want to plot our gerbers. Output directory, gerbers. We want the front copper, the bottom copper. We want the top silk screen. The bottom silk screen we don't need. There's no silk screen on the bottom. The front solder mask, the bottom solder mask, the edge cuts, we don't have anymore. We don't have like fabrication, drawing info or anything like that. So let's not worry about that. Coordinate format, that's fine. Use Protel file name extensions, no. Check zone fills before plotting. Exclude pads from silk screens, exclude PCB edges. Force plotting, do not tent vias. Yeah, we don't want to tent them. Tenting, of course, means to put the solder mask over the vias. You can get to do that at the... You can either do it at the via stage. You can edit... I think you can edit your via. Can you do that in KiCAD? No. There you go. You can't tent. Really? You can't tent an individual via. Wow, that's a bit of a limitation, because sometimes you might want to tent individual ones and not board wide. Is that a thing in KiCAD, really? Wow, that's pretty limited. Many times I've done boards where I've had to tent some vias and not others. That's a massive limitation if that's legit. Anyway, plot sheet references on all layers, plot footprint values. I think we're good. Plot. Hey, it's good that we can run a DRC and we can generate the drill files from here. Generate our gerbers. Because some manufacturers will accept KiCAD files, but no, you want the gerbers. Unable to find the next boundary. Bite me. Okay, where are our files? It's not in the gerbers because they're the old ones. Because it's not 4-layer outer is the name of my project. Oh, I think it's not generating the gerbers because of this error. Cannot determine the board outline. Wow, I don't think it'll even generate them. There's no files in there. It doesn't even generate any gerbers at all. Any layer with that bug. So I've got to fix that. Damn. It's a bit limiting. I'll get back to you. Maybe I can disable the check zone fills before plotting, perhaps. Let's give that a burl. There we go. Yep. All right. So I just ignored the zone fills. And we're good. Do I have to, like, is there like a refresh? Refresh project tree. There you go. Ta-da. There you go. That's our front copper gerber. That looks good. No wuckers. There's no daggies outside there. Oh, it's still got the, it generated the frame in there. It doesn't matter. Like, the manufacturer will get rid of that. It's not a problem. The manufacturer will just ignore that. It's not a problem. So, bottom copper. That looks good. Yep, happy with that. Our mask. It won't open up in the same window. Yep, that looks good. And the edge cuts will just be, as the name suggests, around the outside. Front mask. Front mask looks good. No wuckers. And last but not least, the front silk screen. And always check your gerbers. Oh no, I was going to do the t-shirt. Don't touch my gerbers. Because some manufacturers will. I've done a video on that. I might try and link it in. How a manufacturer modified my gerbers to expand the copper around the pads. It was just ridiculous. And then I had breakouts and my ground plane was broken. It was just insane. The manufacturer should not touch your gerbers without your express written permission. It's ridiculous. Anyway, so those gerbers look good. So we're good to go. So we'll package up those gerbers and the drill files in a zip file, and we'll get this board made. Now, of course, if this was a professional PCB and a lot of money, like, as I said, like one of these boards here or something like that, there'd be a lot more involved in checking this than just a cursory glance. Yeah, you know, she'll be right. No worries, mate. In this sort of board, like a 4-layer board like this, is pretty simple. As long as you don't screw up your ground planes and all that sort of stuff, and it passes DRC and everything's fine. You don't care too much about all the, not fussing over the little details. You just want something to work electrically. Then yeah, no worries. But sometimes you can take a day or two just to check everything, double check, triple check everything before you send it out for manufacture. Because, like I said, like if you're populating a huge board like that, right? You get your board manufactured, and then yeah, it might be 100% electrical tested at the factory, which it would be, right? Everyone does that nowadays. It used to cost you extra, now it doesn't. But if you got a board like that, electrically tested, so, oh, it passes the electrical test, it must be okay. You go put some of those FPGAs are thousands of dollars each, right? Getting one board, I've had boards that cost like tens of thousands of dollars just in parts on the boards. So, and if there's something wrong with that board and you load all the things on and you find that, I don't know, your ground planes are short or one ground plane's not connected because of something or other, that can be a real expensive mistake. Now, I'm in JLCPCB here at the moment. Don't necessarily recommend them, but I don't not. So, you know, it's not an endorsement or anything like that. It's just happened to I use at the moment. So I'll load the gerbers up. Okay, we're uploading our zip file now. The good thing is it can, like it, when I was a boy, not that long ago, really, these online what you see is what you get. Things were just not available. You sent by email. You didn't even upload it via web. You sent it by email to your PCB manufacturer, and the whole, like you wouldn't even get previews back. You just cross your fingers and hope you'd done it right. And here it is, detected 2-layer board. Oops. We had this problem the other day getting the micro supply PCB. There's a new one. I'm showing a video. Whoa. Showing a video to my supporters. That's the new micro supply PCB. And we had troubles actually uploading this to JLC. It wouldn't detect the 4 layers. It had a problem with the way that Altium did power planes. It would actually invert them, of course, and then the software couldn't handle that. And anyway, I finally got it working, but like it took like a day of effort. That was, of course, a test. I was testing everyone to make sure you were paying attention there. When I plotted, I forgot the inner top and the inner bottom. No, I didn't. It was a test. It's taken a while to generate those. All the gerber, the ones with all the polygons. Unable. Yeah, bugger off. We'll try that again. See if it likes it. I don't know how it identifies whether or not which order the stack up goes, though. So you might want to watch that if that's important to you. Detected 4-layer board. There we go. Why does it only show? It only shows top and bottom. I think that's normal. Okay, but that looks good, right? Shows all the silk. They're like the dimensions are right. Everything's, yep. So let's go into the Gerber viewer. It's for reference purposes only and may differ. Bottom. It only does the top and the bottom. It does not have the inner layers. Oh, we're unselecting. There you go. We're unselecting. Got it. Yep. Right, that makes sense now. Okay, but it's only top and bottom. Yeah, if we go into analyze analysis results, it tells us that inner bottom and inner top. Don't know why it's got null there. Maybe because it's done nothing with it, I presume. Generic Gerber file, like it's Gerber file with board outline, generic. No, the others are just generic Gerber files. So it's not showing us the 4-layer. Did it show us before? No, I've uploaded the old 4-layer one that I got manufactured. And it's, once again, it's exactly the same. So I think it only displays top and bottom. I think the JLC Gerber viewer doesn't let us view the inner layers, which is, what a pain. Like they go to all the effort to do all this Gerber rendering and viewing and everything else, yet can't show us the inner layers by the looks of it. So that's it's kind of frustrating. But anyway, let's go through with it. It's detected a 4-layer board. If there's an issue, I'm sure they'll come back to us. All right, stupid bloody screen capture didn't capture my final thing here. I was just showed you the whole process for 10 minutes, didn't capture it. So I got to, here we go again. Anyway, here we go, 4-layer board. We can only get a minimum quantity of 5. I can't order 1, which is pretty wasteful. If I only want 1 and it's a one-off, like they're going to make 5. Anyway, it's got to expend all the fuel coming here on the DHL jet and everything else. So, whatever. Anyway, the interesting thing is that there's no price difference here. Look at the insane price. $32 is the tooling fee. When I was a boy, don't even get me started. $19 for 5 boards. These are large. This is 160 by 230 millimeters. Like, it's just crazy. Anyway, you get no price penalty for the other sizes, like 0.8's the next nearest sort of like standard size, which is half the thickness. There's no price penalty for that. And there's no price penalty for any of the ones in between. Look, it even changes the weight. Does not support 0.6 millimeter. Choose another option. Thank you very much. And 0.4. But 0.4 is a price difference and 2 is a price difference again. So anyway, 1.6, we don't need impedance control. And there's no price penalty for red either. Green or red. It's exactly the same price. Terrific. We might as well go red. Makes the electrons go faster. And there is a difference, of course, if you get gold plating. Hassle, which is hot air surface leveling with lead. This is lead-based. I don't know why they... Some people still want lead, I guess. You do pay a little bit extra. You pay like an extra $6 or something for lead-free hot air solder. Hot air surface leveling. You can think of it as hot air solder leveling if you want. ENIG, which is immersion nickel gold. That's what that stands for, a layer of nickel and then a layer of gold on top. So that's your traditional gold-plated board. You pay, oh, look at this. Oh, look, it's an extra. it's a 15 bucks for the surface finish. Extra fit, it's got to be worth it. It's got to be worth it for the wankery. Come on. The gold plating's absolutely worth it. 1 ounce, you do pay a lot for the 2 ounce copper. You'll pay, there you go, there's the price difference. We only want 1 ounce copper. 2 ounce copper is 70 microns thickness compared to 35 microns thickness for your 1 ounce, a standard copper. So 2 ounce copper is what you want if you're doing real heavy current, you know, switching power supplies and stuff like that. You just double your copper weight, you halve your resistance, really. And it's good stuff. We don't want any gold fingers. We've got like card edge connectors with the 45 chamfer on the edge. We don't have any of that rubbish. We don't want a panel. Fly and probe, you can only get it fully tested. You can't even specify, nah, don't bother testing it, don't waste your time. Castellated holes, no, which is the half cut, the half moon holes on the edge of the board. One different design. Remarks, that's possibly where you could put in the remarks for, I want the gold plated edges, I want edge plating on there or something like that, because JLC, unlike some of the others that I showed previously in the video further back, this one doesn't have like a checkbox or whatever to select the edge plating. So there you go. We don't want our laser stencil, anything like that, so we're good to go. I'm going to order that, and I will get those in a week or so. Then I'll build them up at my leisure, and then I'll be able to do a follow-up video doing the local H field measurements here in the lab, comparing it with the other board, and then I'll do a separate video, hopefully, with some far field measurements, E and H field, when they combine. You know, I've done that video where they combine like that, and then at a certain distance, a certain wavelength distance, they actually electric and magnetic fields combine to create your electromagnetic radiation, which is what you measure in the far field, and that's what you get measured at a test house when you go for EMC compliance testing. You're measuring the far field, basically. So I need like an outdoor area test site, an OATS test site for that, or maybe a EMC test house if I can get it, or, you know, I can even do it myself here in the lab with a couple of rabbit ear antennas, you know, something like that. Not like just bodge it, but it's not great. Anyway, hope you found that video useful. There's lots of information in there, hopefully. It's a long, laborious process to do this. It would have gone, of course, this would have taken me much quicker if I wasn't shooting a video. It's like a half-hour job or something to do this, and boom, it's done, kind of thing. And as I said, designing and getting a more professional board manufactured, I'd go through a lot more checks than this, but I don't care. I'm pretty confident this board is just going to work, need it to electrically work, and that's pretty much it. And I'm not going to look into the stack up of the PCB. It doesn't have, I'm sure JLC on their site somewhere tell you what the stack up of the board is, so the various layers in there. And of course, that's going to make a difference for your EMC. So if you want the least emissions possible, you want to keep the layers. So if you've got a board like this, and you've got a layer on the top, and then you've got your two inner layers, you want the inner layer as close to the top ground, and the bottom, you want it as close to the power plane. Ground and VCC are effectively the same. The bypass capacitors ensure that. Then you want it as close as possible to the plane. So you want the inner core to be thick, and then the outer planes, then the outer signal layers to be as close as possible, and tiny little thin prepregs next to the layer. And they don't give you the option here. There's a controlled impedance option, yes, but that just tells you the standard. We could go look that up, but I'm just going to go for their standard stack up. I'm not too fussed. I just want to see if there's any sort of dramatic difference between having the layers on the top or having them on the inside in terms of H field and eventually far field measurements. So that's the plan anyway. So I hope you enjoyed that video. If you did, please give it a big thumbs up, and as always, discuss down below. Catch you next time.